present tray dryers in food industry. So here is my colleagues, members for this experiment. Hafizhuddin BIn Nasir, Hani, Zarith, Alia, Faten, Farahin, and me, myself, Fauliyana. So here's the content. There will be 8 slides. The first, introduction. Second, customer requirement. Third, a process description of the plant. Fourth, a process flow diagram of the plant. Fifth, equipment list and description. 6, safety and consideration. 7, economic analysis, and the last one, conclusion. So I'm going to do the introduction part. So drying can be defined as the removal of water or organic solvent from a substance. So example of dryers, we have tray dryers, continuous tunnel dryers, and drum dryers. So for our experiment, we are going to use the tray dryers. So here's the equation for drying rate during constant rate period. So RC basically is drying rate constant period. HV is the total heat transfer. TB is the temperature of the drying rate, which is measured the dry bulk. TI is the temperature of liquid, which measured the wet bulk. So we have 2 graphs here. The first graph is the moisture versus time. So as we can see, over the time period, the moisture will be decreasing. Okay? And this one is the drying rate versus the moisture. We have the constant rate and the falling rate. So for the constant rate, basically the substance is initially wet, and as for the falling rate, the moisture will be dry. So our objective, we have 2 objectives. The first one, we want to investigate the air temperature versus the drying rate, and the second one, the air velocity effects on the drying rates.
Thank you, Faul. So now I'll be presenting on the customer requirement for tray dryers. Tray dryer is the function of tray dryer is for drying of food. So this is to inhibit growth of unwanted microorganisms that could damage the food, and also to reduce the transport and storage cost by reducing the weight and bulk of food. This is very beneficial for the food manufacturers. The requirements of tray dryer that is needed by the food manufacturers are the mode of operation, physical form of feed, heat sensitivity, production rate. So these 3 properties has to be considered when they need to buy the tray dryer. The next is the types of tray dryers available in the industry, which are the hot air tray dryer, atmospheric tray dryer, temperature tray dryer, vacuum tray dryer, and the electric tray dryer. The most frequent tray dryer that is being used is the vacuum tray dryer. This is because it is being used to dry food that cannot resist high temperature. It is also to dry high grade, temperature and oxygen sensitive products. And it is also used for small scale production of newly developed products. So for my next part, I will be explaining the process description of the plant. So this is the process flow diagram of the plant. So first, the fruits or the vegetables. We can assume it as banana or any kinds of vegetables. First, we treat it by peeling, slicing, some it see for the PFT that here is the part where there are the treatment. Right, for the second one is sorted. The fruits are sorted accordingly, where the damaged fruits or vegetables are separated from the flow of process. Third is the dehydration. From the process flow diagram, the dehydration is over here, where the water is sent to the evaporator for the water to be evaporated. Then it is sent to the activated carbon black and then to the syrup tank. This process is a recycle. This is a recycle process, as the water is continuously flowed in the process. After dehydration is washing. The fruits are washed thoroughly, and it's the waste of the product is then drained. Next, the most important part is the fruits entering the vacuum dryer, which is our unit that are explained further afterwards. And lastly is the packing and storage for the fruits or vegetables to be sold.
Hello, my name is Hafiz. So basically, as shown previously, this is our plant process flow diagram. Consists of the whole process from the raw material, which is banana, until the products. So basically, there are minor units and also major units. So I'll be brief on the minor unit first. So firstly, there is sorting and storage conveyor, which function basically is to transport the raw material, the banana, throughout the process from the initial to the final product. And the next minor unit is the washing tanks. This is where the raw material of banana is washed to clean it from any impurities. And the next one is peeling machine, chopping and slicing machine, which both are used to reduce the size of the banana into smaller pieces. And lastly, the minor unit is our storage tank. Basically, it was used to store our finished product. As for the major unit, we'll start with the sulfiting tank. So, sulfiting tank is basically a tank in which sulfitation process takes place. SO2 is introduced to the fruits to prevent either microbiological degradation or unwanted color formation to occur to the fruit, which means the fruit will be preserved better. And the next is osmotic dehydration tank, which is the heart of the process. Inside the tank, basically, osmotic dehydration takes place. Osmotic dehydration is where the water from plant tissue is partially removed by immersion in a hypertonic solution. And last major unit is of course our vacuum tray dryer, which is used to draw out liquid from the processed raw fruits to inhibit microbial development and quality decay, hence extend the product shelf life. So moving on to our main unit in this process, which is the vacuum dryer. So basically, from our experiment, we use tray dryer. In this process, we use vacuum dryer which have the same application as the tray dryer. So vacuum dryer is characterized by its ability to remove liquid at low temperature and also to recover back the liquid which has been removed. So vacuum drying is a batch operation. This gives it the advantage to make it extremely flexible and multi-purpose. A vacuum dryer can handle many material from thick slurries to solid, which in our case is the fruits and the bananas. Vacuum drying cycle times are depending beside product characteristic on several key factors, which is the pressure, temperature, surface area, and also heat transfer coefficient. For pressure, in vacuum dryer, the pressure ranging from few millibar to few hundred millibar for evaporation of solvents. It is most economical generally to produce a vacuum by passing the vapors first through a surface condenser and then to a vacuum pump. This ensures only a small flow goes to the vacuum pump. As for the temperature of the dryer wall depends on the maximum allowable temperature permitted by the solids. A water circulating heating system is usually most economical when the temperature is below 100 degrees C. As for the surface area, in a conical dryer, the surface area of the heated wall is less than proportional to the volume, so the drying time becomes faster in a smaller dryer. And lastly is the heat transfer coefficient. Heat transfer coefficient is product depending parameter, but products tend to have 4 to 6 times bigger heat transfer coefficient compared to dry material. So basically this is the result we obtained from our tray dryer experiment. Generally, for experiment part A, we vary the heater which have different temperature, and for heater A fan 1 and also heater B fan 1. So the graph here shows the same pattern. In the moisture content versus time graph, the moisture content will decrease with time, and as for the drying rate versus time, we can see that the drying rate is faster initially and gradually decrease as the time increases. As for part B, where we vary the air velocity, fan 1, heater B, fan 2 also with heater B. So the same pattern can be seen. The moisture content versus time graph, the moisture content will decrease with time, and also the drying rate versus time graph. Initially the drying rate is fast. As the time increases, the drying rate also increases. And that's all for today.
Okay, hi everyone, my name is Faten. I'll continue from the previous part. So my part is economic analysis. So basically this part is about the cost of the plant, the raw material, and the machinery, the equipment. So okay, for this plant, I assume the capacity of the processing is 2,000 ton per year. Well, so the total operational per day can be calculated as follows, which is 1 year equal to 365 days, 1 ton equal to 100 kilograms. So you calculate here, divide by 365 days, you got here 548 kilograms per day. This is total operational per day. Okay. So another assumption for this plant is the hydrated vegetable processing project. This project required, this plant required 4,000 square meters of the land itself. So the land requirement is 4,000 square meters. Okay. So this is basically the rough I assume the calculation, the cost for the equipment and machinery. So we got here total 0.52 million for the equipment and machinery. Okay, so for the land requirement, just now I said it requires 4,000 square meters, right? So 1 square meter is, I assume it's 40 million. So the total, for the land, 1 square meter, I assume it's 10,000. So we got 4,000 square meters. So here the total is 40 million ringgit. Okay. So the building requirement is, I just assume the basic building. So after I total up, this one is in square feet, and then this one for 1 square feet is equal to this one, this construction cost. So the total building is here, 8.64 million. This is for the building requirement. Okay, after I total up, sum up all the requirement, machinery, land, and the building requirement, I got here, plus here, the raw material, which is the raw material for our industry. So we got here 49.57 million. Okay, I'm done with the academic analysis part. I'll just proceed to the safety and other consideration. As you all know, in the plant itself, we got all the machinery, mechanical and electrical equipment. So this is a basic safety and consideration that we need to pay attention. So I just good plant design can minimize the extent of any hazardous area. The second one is good ventilation can prevent accumulation of methane in sludge storage tank. And the rest you can see from this slide. Okay, next. This is the safety that we need to pay attention for the fire and explosion. Okay, next. Okay, the safety systems of the work. Okay, this one is for the whole plant and the workers, the transport and all the basic safety is in here, the safe system of work. So just the key point is that the regular check is really needed in this case because for this one, the plant when the plant is not running, we still need to check it regularly because we need to ensure that the mesh panels are in place. Okay. And for this industry, tray dryer, in this food industry, this all involve the hot work. So we need to clean up regularly the equipment from the material, the hazardous material. I think that's all from my part. Thank you.
So in conclusion, for our experiment, drying process is one of the migration water from the interior of the solid towards the substance. Towards the surface. So the factors that the factors that determine the rate of drying is the air temperature, air velocity, and the moisture itself. So in conclusion, air temperature and air velocity are proportional to the drying rate.